better than, at least I think, better than how is it made.
Where does this pie come from?
Scientists are egotistical, lazy people. So you might think lazy and go, they'll just take the pie. Remember, they're egotistical. Scientist sees that pie and says, I can make it better. Okay? That's what we're doing as scientists. We see something, anything, and say, I can make it better. Okay? An apple fell out of that tree, I can make that apple fall faster. Okay? I can make that pie taste better. So they deconstruct it. They come down to the basic ingredients of it, all the little pieces, and say, okay, I can change that, I can change that, I can change that. And they go through the process again and try and make a better pie. Okay? Meaning all this isn't true. Biologists don't do this. Are you kidding me? That's exactly what biologists do. They see life and say, hey, that's pretty cool. I want to make that life. How does that life work? So they go apart, and what do they do to that life? First thing, they kill it. Good job, biologist. Cut it open and look at all the pieces into it and try and come up with how to deal with those pieces. Okay? Chemists really aren't any better. They take the remnants that the biologists threw away and chop those up even further. Okay? And what do physicists do? Physicists take a look at the pieces that the chemist chopped up and threw those away, and then the physicist will say, yeah, I can look at that too. Okay? Then what do mathematicians do? Say, y'all are crazy. I don't even want to look at the animal. I'm just going to write down some numbers and make it work. Okay? So all of these fields are interrelated within science and looking at it at different scales. But it's all ultimately about the same idea of, I want to know how this works so that I can do it better. Okay? And there are varying levels of egotism within it. Okay? Sometimes it's really blatantly obvious. You look at a primary scientist and what do? They publish. How many authors are on their papers? One. Who's the one author? They are. Were they in the lab? No. Did they write the paper? Probably not. Did they do anything in regards to the paper? They probably read it. Okay? Probably told whoever wrote it that a comma was in the wrong place. Okay? So we get differing levels of egotism, but it's all coming back to the same idea. I just want to know how this works so that I can do it better. Okay? And that's what we're trying to do. And we come up with different rule sets to figure out how to do this. For instance, this pie. Okay? What's a rule set that you might come up with already?
Your ingredients list.
What are the ingredients? Is cow dung going to be on there?
I hope not.
Probably not. There's a rule list. So part of this class is, here's these rules. And yeah, it kind of sucks that we have to memorize these rules, but that's what we have to end up doing, is we memorize these rules so that we can better understand how this worked. Because when we first try and disassemble this into the pieces, we're taking apart each of those pieces and coming up with a way to describe it. For instance, what is this piece right here? You just came up with a name for that. Where did that name come from? Somebody before you said that that piece is a strawberry. Okay? We're doing the same thing for chemistry. For instance, what is that? Okay, let's pick an easier one maybe. Let's try that one.
Iron.
Iron. Well, how'd you all know that? You had a naming, you had a rule system allowing you to go through and process that. Okay? We have built up these rule systems intuitively, naturally, through just random interactions with people, okay, and other scientists. But we don't have them fully fledged and formed yet. Okay? And that's partly what this class is trying to do, is to get you closer to what those rules are so that you know how to apply them more appropriately. Okay? So how can we go through and do this? Well, scientific method shows up. Okay? So let's look at a scientific method. Paul heard of this. How many people have heard of the scientific method? Sizable number of people. Okay. When we think of scientific method, we've got some rule sets associated with it on how we want to structure our thought process. And this is probably one of the most disingenuous things that scientists can do, is we teach you this method and say this is how it works. Okay? And your textbook has this in it, and it drives me up the wall too. Okay? So ultimately it's learning something new. So it starts off with this observation. Once we've got an observation, what do? Some of you knew the scientific method. What happens after an observation? Ask a question. Okay? which was supposed to show up in there in the middle. It's supposed to say hypothesis. For some reason, it's not there. And then we run an experiment. So we design an experiment to test that hypothesis. Okay? And this is the part that I find so frustrating. Okay? Because what do we tell you then happens after we've done this? We go from an experiment to a conclusion. Fantastic. So everybody gets this idea of this is what science is. Okay? It's all about getting that conclusion. That's science. You go through this nice linear fashion. Everything's beautiful. It works. It's perfect. It's also completely wrong. Okay? That's not what science is. What is science? Failure. Okay?
Do we teach?
Sometimes I'm a little bit more politically correct than others. Okay? I'm really bummed that that hypothesis isn't showing up in there. I'll have to keep writing it in. Everything fails in the experiment. Okay? Our hypothesis was wrong. So we go back to the hypothesis and say, well, let's change this. I'm going to make a new hypothesis. With this new hypothesis, what do I have to do? Another experiment. So we set up another experiment. Science only fails once, so of course then we move to the conclusion, right? Nope. We go right back with a bunch of lines, right back to the hypothesis. Well, we got a new hypothesis, so what do? Another experiment, what happens?
Can fail.
Another failure. And another failure, and another failure, and another failure. Okay? And why is this such a disingenuous thing to do? Well, when you get into chemistry or any of the real sciences, what ends up happening? You get frustrated because what do you end up doing? Failing. So, oh, this is horrible. There are all these brilliant dead people that could do this material. My teacher can do this material. Maybe. Okay? But I can't do it. Okay? Every single teacher, professor, scientist fails. The best scientists and researchers out there didn't fail once. Okay? And it generates an euphoria, something that they just get super, super excited about. They spent 20 years failing, and in 5 minutes they had one success. And with that one success, they go, I can go another 20 years of failure. That, unfortunately, or fortunately, is what science is. It's picking yourself up after you failed to do it again, which is kind of odd because that's also the definition of insanity. Okay? But that's what we're trying to do. Okay? So part of what I want to transfer across to you guys in the course of this class is that failure is okay. We just have to decide when to fail. Okay? And we want to do our best to set up our failures when? The end of the semester, we want our failures? I would really prefer that not to happen. We want our failures to happen throughout the semester, but have built up enough failures that when we get to the exam,
It will be a success.
it's the success. And then what do you do after exam 1? You go right back to failing again. Okay? And you fail and you fail and you fail for 3 or 4 weeks, and then you get to exam 2, and then what happens? Success. Okay? So you are building on failures. I know that sounds like a horrible thing to say, but it's actually a very bright, useful thing to say. It's optimistic because you already know you're going to fail. Okay? If you started everything where you always knew you'd succeed, you'd get kind of bored of it. You're like, well, why would I bother doing this? We need that little bit of a challenge within this. So I'm going to try my best, as odd as it may sound, to set you up to fail. In the homework, in the practice. But with all of that setting you up to fail, I'm trying to set you up to succeed for the finals and the exams on where it counts. To set that up, you have to be doing that practice, both outside of class and in class, to make sure that when it gets to the exam, you are ready to succeed. Okay? This could be a depressing question. How many people are excited? Was that not excited? Is that why you dropped your hand? Okay.
Does it help to
Inspirational. Okay, I'm trying. After we get through this whole experiment, it then can separate out, as your textbook says, into two kind of categories. You get a scientific theory and you get a natural law. Okay, those are your two main subcategories. Your theory continues to get refined. Okay, but it was enough of a success from our experiment that our hypothesis was at least partially true, that we can now actually say we've added scientific knowledge. There's our theory. We can then continue to refine that. Our natural law is something that we observe, and that's the end of it. You can't really break that. Okay? Natural laws are becoming more and more difficult to discover, okay, because people have already kind of discovered those. What we're working on now is building those theories. What else can we do? How can we tweak things? How can we change things to make new stuff? Okay? And we got lots to do there. Okay? For instance, does anybody know anything about what's going on inside your head? Because I'll tell you right now, I don't know anything going on in my head, and it is one scary, hellish place to be. Okay? Which I would agree that probably all of your heads are probably the same thing, which comes up to testing. When you take a test, most people just bubble in the answers. You just spent the entire test where? Trapped inside your head, which was hell. Get out of your head. Write it down. Okay? Fun little rhyme that's randomly happened to pop into my head a little while ago is, when in doubt, write it out. Okay? Write everything down. It will help you. It'll get you out of that scary little place to be. Okay? Particularly when it comes to exams. So, chemistry's role is kind of a bridge between all of these scientific fields. I told you. We've got mathematics and physics on the kind of pure, it's not applied, the pure brainiac basic science stuff. And then on the other side of the continent, we've got biology and other stuff. Why not? Right? And what chemistry is trying to do is bridge those two gaps, those two individual fields. Engineering does something similar. Okay? What we're trying to do is bridge our understanding between the raw basic science, the mathematics and the laws and the physics that allows things to occur, and actually take them into an application process with our biology and other fields. Chemistry does that, okay, through different branches. So chemistry subcategorizes out into at least 4 primary categories. Organic chemistry, my favorite, of course it's first. Biochemistry, which is actually my least favorite, so it should have been last. Inorganic chemistry, and physical chemistry. All of them, again, do varying extents and allow various interlinking between them. Okay? So what we're trying to do within this class, interestingly enough, is really we only kind of talk about the inorganic and the physical. Okay? Which is sort of odd because really we don't talk about inorganic or physical chemistry, but that's the best way to categorize this class. We're centered in those two areas. What are the rules that apply? So what physics applies into our physical chemistry? How do gases move? How do solids move? How do liquids move? Okay? And inorganic chemistry. What are the things that are moving? Well, it's all the stuff on the periodic table that's not organic. What's organic on the periodic table? Pretty much anything that contains carbon. So how much of this class is covered on the periodic table? Slightly panic-inducing. There's 118 elements, only one of which is not inorganic. Okay? That's a lot of stuff we're trying to get through and cover. Okay? Realize the breadth. We will narrow it in and look at more specific examples to try and make it a little bit easier. So that was an exciting chapter 1. All done. Questions? Chapter 1. Deep breath. You guys look awfully excited to be here. You telling me all you knew this information already? I don't really see anybody writing stuff down. You all knew this? Okay, I lied. Some of you writing stuff down. So, some more information. Course ID for Mastering Chemistry. You need this code. McFablin SP15. Okay, it will ask you for that code. If you don't have that code, you cannot get access to the Mastering Chemistry. Okay, the homework due dates will be found within Mastering Chemistry. I've tried to update them on Canvas or in lectures, and it just becomes a pain. Realize you're looking at probably 2 to 3 assignments per week. Mastering Chemistry is big enough and been around long enough that they've got timelines on them. Those 2 to 3 assignments, depending on the level of difficulty, are trying to take anywhere between 30 minutes and an hour. Okay, is what I'm trying to get each. Okay, so there's 2 sets of homework assignments. There is a pre-lecture assignment. Pre-lecture. I'm going to ask you questions about stuff that you haven't even been lectured on? Hell yeah, I am. Because that's what you're supposed to be doing, is reading the textbook before you come into lecture. So when I'm talking, you understand what I'm saying. Or at least know, hey, that was confusing. Talk about that again. Okay? Those questions are designed to take 30 minutes. Those are going to be the shorter of your 2 assignments. Okay? And they are pretty much just reading questions. So if you've read the textbook, you at least know where to look within the textbook to find answers. The second type of assignment, which will be a little bit longer, I think I've just called homework. Okay? You should be doing that assignment while we're lecturing on the material. You'll actually have to do a little bit more work within the assignment, maybe actually solve some problems. But again, it's not something you should wait until we're done lecturing about it. You should be working on it as you go. Ideally, if you maintain this, the homework will never get burdensome, and everything will run nice and smoothly, and when you get to the exam, you rock the exams, and everybody will be happy, including me. Make sense? Okay. Only got another hour left, so we got to step it up. So when we move into chapter 3, no one even turned around. You didn't even challenge me. We're done.